Welcome to this video on day 2 of solving quadratic equations using the square root method. To recap, we can use the square root method to solve quadratic equations if there's no bx term, meaning there's no coefficient with a single variable. We can have ax squared and we can have c, but no bx term. So let's take a look at some of these examples. They're a little different than what we talked about previously. So when we take a look at number 1 here, you'll see that this entire expression right there is being squared. That is our ax squared term. We want to get that piece all by itself. So you'll see that there is a 5 multiplying to that. So we don't want the 5 there. We want to isolate what's being squared. So since it's 5 times, we're going to divide the 5 out. And we're going to be left with x minus 1 squared equals 9. Now, this entire expression is being squared. So when we square root both sides, the square root will cancel that squaring, but we have all of x minus 1 equals, and remember when we take the square root here, this is plus or minus 3 because both would make the statement true. So when we go to solve this, we have a little bit more of a complication here. It's not just x equals plus or minus 3, it's x minus 1 equals plus or minus 3. So we actually need to still solve for x. So we have two equations here, once when this 3 is positive and once when this 3 is negative. So we're going to write it twice. X minus 1 equals, I'm going to put positive 3, and we have x minus 1 equals negative 3. Now, to get x alone on this equation, I'm going to add 1, and now I have x alone because those ones canceled out. X equals, we have positive 3 plus 1 is 4. Now over here, I'm going to add 1, but this time it's negative 3 plus 1, which is negative 2. So the graph of this equation would go through at negative 2 and positive 4. So it's a little extra step that we got to pay attention to. Let's try it again. This one's a little more complicated. What we're trying to get alone is this parenthesis term, because that's what's being squared. Everything else has to be moved away in order for us to do this. So first thing we're going to do is we're going to subtract 3 from both sides. Then I'm left with 4 times x minus 3 squared equals negative 3. Then we're still trying to get this squared term alone, so we'll divide this by 4 and this, so we can get this 4 to cancel out. That's going to get us our term by itself like we wanted. X minus 3 squared equals negative 3 over 4. Now what we want to be alone is alone. The squared term is alone, so we can take the square root of both sides. And we're left with x minus 3 equals. Now remember, when we look at fractions, this is really saying the square root of negative 3 over the square root of 4. And it will be plus or minus. Now the 4 is not a problem. Where we do come into a problem is right here. If you take your calculator, and we're going to put in the square root of negative 3 to find out what that is. That says non-real answers. You cannot take the square root of a negative number and have a real answer. So we have to stop, and we're going to say here that there are no real solutions. That happens sometimes. It just can't be solved this way. So there's no real solutions. There's something called an imaginary solution. You'll get into that in later math classes. Okay, let's try number 3. It was a little disappointing, but we'll move on and try number 3. What we want to get alone is x plus 2 squared. Everything else has to move away from it. So we'll start with subtracting this 3. You do addition or subtraction first. We have 1/2 times x plus 2 squared equals 12. We need to get rid of the 1/2. It's already dividing by 2. So if I multiply by 2, I can get this 1/2 to cancel to 1, leaving x plus 2, it's still squared, equals 24. We're going to square root both sides. Remember, the square root cancels the squaring here, and we have x plus 2 equals plus or minus, let's break down 24, 8 and 3. And 8, if you remember, we like to say is 2 times 2 times 2. So we have a pair of 2's that will come to the outside, and that's the only pair. And a 3 and a 2 are left behind, so they're going to go back in as 6. Okay. Remember, this represents 2 solutions, so because we don't have x alone, we're going to have to write this twice. X plus 2 equals positive 2 root 6. X plus 2 equals negative 2 root 6. Now when I solve both of these for x, I'm going to subtract 2. My subtracting 2 will not combine with this. It's going to be a separate term, so I'm going to put it in front. We like to put that in front. So I get x equals negative 2 plus 2 root 6. Over here I'm going to subtract 2, and I get x equals negative 2 minus 2 root 6, because this one is a subtraction one. Now, you'll notice they're exactly the same except for the signs, so often you will not see them written side apart like that. You're going to see this written as negative 2 plus or minus 2 root 6. This is the preferred method of writing this. Okay. Now one last one, we'll do some practice to kind of hone this in. We're trying to get this x squared alone. It's in this fraction, so we got to get everything that's other than the fraction away, and then we'll start dealing with the fraction. So we have a plus 8, so we'll subtract 8 from both sides. So we have x squared divided by 5 equals 12. The 5 is dividing, so if I multiply by 5, that's going to be able to cancel to 1 right there, leaving just the x squared, and 12 times 5 is 60. My squared term is alone, so I am going to take a square root of both sides. Let's see how 60 will break down. We have 6 and 10, 2 and 3, 2 and 5. We've rewritten those, so be sure you don't look at them anymore. We do have a pair of 2's right there, which means a 2 will go in front. And we have a 3 and a 5 that are going to go back underneath. So it would be 2 square root 15. The radical cancels the squaring, leaving just x equals plus or minus. Now x was alone because everything else canceled out from that side, so we don't have to worry about moving anything else over. That's going to be our final answer there. Hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.
Yeah.